Welcome to the peaceful space of sleep-friendly science, where we'll drift back in time to witness the single, pivotal moment that gave rise to every plant, animal, and fungus on Earth. Tonight, our story takes us to the vast, ancient oceans of a young world. Imagine a time before complexity, when life was just a single cell. We will explore the strange and beautiful tale of an unlikely alliance, a microscopic merger that would change the future of life on our planet forever. Now, settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The stage is set. A primordial world. Let the world outside your window fade away. Let the sounds of your day soften into a distant echo. We are traveling now, not across space, but through an ocean of time, so deep that memory itself has not yet been born. We are going back to a young and solitary Earth, some 2 billion years ago. Imagine yourself as a silent observer, floating in the warm, primordial sea. The world you see is not the familiar blue and white marble of today. The sky above is a strange, hazy orange, painted by a methane-rich atmosphere. The sun is a younger, dimmer star, its light filtering down through the murky air with a soft, coppery glow. There are no continents as you know them, only the dark, jagged peaks of volcanoes piercing the surface of a global ocean, islands of black rock in a world of water. There is no birdsong, no rustle of leaves, no sound at all but the deep, slow pulse of the planet itself, the hiss of volcanic vents, the gentle lapping of waves on sterile shores, and the profound, overwhelming silence of a world without complex life. This ocean is not empty, but it is not teeming. It is a thin, chemical soup, a liquid cradle holding the first, tentative experiments of biology. Life is here, but it is a shy and simple thing. It is life on the scale of a whisper. There are no fish, no seaweed, no shells on the seafloor. There is only life as a single solitary cell. Trillions upon trillions of them, each a self-contained universe, drifting through the currents, living and dying in a drama unseen and unrecorded. They are the sole inheritors of this lonely planet, the quiet rulers of a water world. And it is here, in this vast and silent theater, that our story begins. It is a story not of kings or empires, but of two of these microscopic beings. Two souls, if you will, whose unlikely meeting would rewrite the future of all existence. Let us meet the first of our protagonists. Imagine, drifting before you, a being of profound simplicity. It is an archaean, one of the most ancient forms of life. Picture it as a soft, translucent sphere, a living cloud 1,000 times smaller than a grain of sand. Its boundary, its cell wall, is not a rigid fortress, but a delicate, permeable membrane, a mere whisper of a division between its inner world and the great ocean outside. It is more a suggestion of a self than a declaration of one. Inside this sphere, there is no complexity as we know it. There is no nucleus, no control center. There is only a soupy, gelatinous fluid called cytoplasm, and suspended within it, like a tangled thread of starlight, is its genetic code. This is its memory, its blueprint, its entire inheritance from a billion years of survival, a simple, elegant scroll of instructions for how to be. The life of this archaean is a slow, meditative dance. It does not hunt. It does not chase. It simply is. It drifts on the gentle currents, bathing in the chemical richness of the sea. It sips nutrients that diffuse across its membrane, molecules of sulfur or hydrogen, whatever the deep-sea vents might offer up from the planet's core. Its metabolism is a slow, smoldering fire, providing just enough energy to maintain its form, to repair its delicate wall, and, every so often, when conditions are just right, to perform the patient miracle of dividing itself in two. Its existence is a quiet one, a life lived in a perpetual twilight limited by the meager energy it can extract from its surroundings. Think of it as a gentle monarch of a tiny, silent kingdom, a kingdom that extends no further than the surface of its own body. It has no ambition, for it has no concept of anything more. It is a perfect, self-contained dream, floating in the endless night of the deep ocean. It is stable, it is ancient, but it is also limited. It exists on the edge of possibility, surviving but not truly thriving. Now shift your focus. Look for something different in this endless expanse of simple beings. There, a flash of movement, a darting speck of vitality. This is our second protagonist, a bacterium. It is much smaller than the archaean, a tiny, streamlined vessel of life. But what it lacks in size, it makes up for in vigor. While the archaean drifts like a dreaming island, this bacterium moves with purpose. It is a living engine, propelled by a whip-like flagellum that spins with furious energy, a blur of motion in the slow-motion world of the deep. This bacterium holds a secret. It is a pioneer. It is a master of a new and dangerous magic, a form of cellular alchemy that is just beginning to change the face of the planet. For you see, a new substance is slowly seeping into the world's oceans, a waste product from other, sun-loving bacteria near the surface. This substance is a powerful, volatile gas. To most life on early Earth, it is a deadly poison. This gas is oxygen. But our little bacterium has done something remarkable. It has not recoiled from the poison. It has embraced it. Through the patient work of evolution, it has forged the tools to tame this volatile element. It has learned how to breathe. It can take in a molecule of oxygen and use it to shatter organic matter, releasing a torrent of energy that was previously unimaginable. Think of the archaean's slow, smoldering fire. This bacterium, by contrast, holds a controlled lightning storm within its tiny body. The energy it creates is immense, a staggering fortune compared to the spare change its neighbors live on. This energy fuels its rapid movement, its quick repairs, its fast replication. It is a spark of furious life, a keeper of a tamed fire in a world terrified of the flame. It is a marvel, a testament to life's ingenuity. And yet, it too is alone. It is a tiny, powerful engine, but it is still just a single cell adrift in a vast and increasingly dangerous chemical sea. Its power is great, but its world is small, and its existence is just as fragile in its own way as that of the slow-drifting archaean. So, the stage is set. Two beings, floating in the same ancient water, yet living in different universes of energy. One, a large, slow, simple host, with ample space and resources but living on the edge of an energy famine. The other, a small, vibrant guest, holding the secret to almost limitless power, but vulnerable in its solitude. They are two halves of a puzzle that has not yet been formed. Two notes of a chord that has not yet been played. They drift through the silent darkness, unaware of each other, unaware that the entire future of the Earth hangs on their chance encounter. Their paths, governed by the random currents of a 2-billion-year-old ocean, are slowly, inevitably beginning to converge. Section 2, Life of the Larger Host, the Archaean. Let us return our gaze to that slow, drifting world within a world, the Archaean. Let us float beside it for a time and try to understand the rhythm of its existence. To call its life simple is both true and a profound understatement. It is a life distilled to its purest essence, a state of being that has been polished smooth by a billion years of continuity. Imagine its membrane, the very edge of itself. It is not a wall of stone, but a living, breathing border, as delicate and dynamic as the surface of a soap bubble. It is a frontier of constant negotiation. Through this shimmering, flexible skin, the Archaean perceives its universe. It has no eyes, no ears, no nerves. Its entire body is a single, unified sensor. It tastes the water, not with a tongue, but with its entire being. It feels the subtle shift in temperature as it drifts nearer to a hydrothermal vent, a deep-sea chimney breathing warmth and minerals from the Earth's molten heart. It registers the presence of a sulfur compound not as a smell, but as a change in the electrical potential across its own skin, a faint, welcome tingle that promises sustenance. This is a perception so alien to our own. We experience the world through specialized portals: our eyes, our ears, our skin. The Archean experiences the world as a whole. It is a living drop of water that is aware of the ocean it inhabits. Its consciousness, if we can even call it that, is a diffuse, gentle awareness, a constant, quiet hum of "here I am." Step inside that membrane with your imagination. The interior is a sanctuary of quiet chemistry. There is no bustling city of organelles, no nucleus holding the sacred texts in a central library. Here, the genetic story of the Archeana single, circular thread of DNA floats freely in the soupy cytoplasm. It is a coiled secret, a recipe for survival passed down through countless generations, a song of its ancestors sung in the language of molecules. This free-floating design is the very definition of a prokaryote, a life before the kernel, before the nucleus. It is an open-plan existence, a life without walls or divisions. The Archean's life is lived on a shoestring budget of energy. It cannot afford the vibrant, high-speed existence of our other protagonist. Its metabolism is a form of chemosynthesis, a quiet and patient magic. It doesn't eat in the way we understand. It absorbs. It sips the dissolved minerals from the seawater: hydrogen sulfide, ammonia, ferrous iron, and with a slow, deliberate series of chemical handshakes, it breaks their bonds to release a tiny whisper of energy. Think of it as a candle flame in a vast, dark cavern. It is enough to see by, enough to provide a small circle of warmth, enough to sustain life. But it is not enough to truly illuminate the darkness, nor to fuel great works. This energy is carefully rationed. A little for repairing a tear in the membrane, a little for maintaining the delicate balance of salts and water within its body, a little for slowly knitting together new proteins. There is rarely a surplus. There is no energy for grand projects, no fuel for ambition. And because of this, the Archean exists in a state of profound contentment. It cannot want what it cannot imagine, and it cannot imagine a life of greater energy. This world is stable, its needs are met. It is a perfect embodiment of survival. And when the slow feast has been sufficient, when the gentle income of energy has finally built up a tiny surplus, the most momentous event in the Archean's life can occur. A quiet, internal signal is given. The floating thread of DNA begins to replicate itself, creating a perfect, shimmering echo of its own code. The two scrolls of life drift to opposite ends of the cell. Then, the cell itself begins to elongate, stretching gently. A soft furrow appears around its middle, a subtle cinching of the waist. This groove deepens and deepens, like a drop of oil in water about to divide. There is no violence, no struggle. It is a graceful, silent process, a yielding to the fundamental urge of life to continue. Finally, with a soft parting, the one becomes two. Two perfect daughters, each an identical copy of the parent, each carrying the same ancient song in their heart. They do not drift far. They are now neighbors, two gentle ghosts in the twilight sea where, moments before, there was only one. This is not birth as we know it with a parent and a child. It is a continuation, a ripple. The self simply expands and divides, a quiet act of immortality. This is its life, a slow drift, a patient sip of chemicals, a quiet division. For 1 billion years, this has been the peak of biological achievement. And in this perfection, lies a profound prison. The Archean has reached an evolutionary plateau. Its design, so elegant and successful, is also a cage. The reason is a simple, brutal law of geometry. As a cell grows larger, its internal volume increases much faster than its surface area. For the Archean, whose entire livelihood depends on absorbing nutrients through its surface, growing larger would be a death sentence. It would be like a city whose population grew 1,000 times, while its roads for importing food remained the same. Starvation would be inevitable. Cannot get bigger. And with no way to get bigger, it cannot become more complex. Building new internal structures, muscles for movement, nerves for thought, organs for specialized tasks, all of this requires a vast, unimaginable surplus of energy. An energy that its slow, smoldering fire simply cannot provide. It is trapped in its own perfect, efficient, and minimal design. It is the pinnacle of simple life, but it has no path forward. Can make more of itself, but it cannot make anything new. It can fill the oceans with its quiet, ghostly presence, but it cannot build a forest, or a coral reef, or a single thinking mind. It floats on, unknowing, unaware of its own limitations, unaware that the key to unlocking its own boundless potential is not a treasure to be found, but a traveler to be met. It drifts in its peaceful, eternal present, waiting for a future it could never conceive of. Section 3. The energetic guest, the bacterium. Now, let your focus soften and drift away from the slow, gentle giant. Pull your awareness back into the vast, dark water, and listen. Listen with your mind's ear. Beneath the deep, planetary hum, you might just perceive a new sound. It is not the slow, resonant note of the Archean's existence. It is a high-frequency vibration, a tiny, insistent hum of pure vitality. Look for its source. There. A pinpoint of light, a flicker of directed motion against the slow-motion ballet of the deep. This is our other soul, the tiny, vibrant bacterium. Let it draw closer to your mind's eye. It is a fraction of the Archean's size, a sleek and compact vessel, shaped like a tiny rod or a grain of rice. It is life stripped down not for simplicity, but for efficiency. It is built for speed. Its body is a testament to purpose. And from one end of it trails a filament so fine it is almost invisible, a long, corkscrewing tail. This is its flagellum. It is not a passive rudder, but a spectacular molecular motor, a propeller that spins thousands of times a minute. It is the source of that hum, the engine that drives this small being through the water with a ferocious and beautiful agency. While the Archean drifts, this bacterium travels. It is a hunter, a seeker, a pilgrim on a constant quest. It leaves a shimmering wake in the still water, a fleeting trail of its own determination. It is a living spark in the endless, sleepy dark. To understand this creature, we must understand its secret. We must understand the profound and dangerous pact it has made with the changing world. For at this time in Earth's history, a great transformation is underway. High above, in the sunlit shallows of the ocean, a new kind of life has flourished, cyanobacteria, and these beings are breathing out a waste gas, a substance so reactive, so ravenous, that it tears apart the very molecules of life. It is a ghost that bleaches the world, a slow-motion fire that rusts the planet's rocks and poisons its inhabitants. This gas, this elemental curse, is oxygen. To the quiet, ancient life of the deep, like our Archean, oxygen is death. It is a corrosive toxin to be avoided at all costs. Their slow, delicate chemistry cannot withstand its aggressive embrace. They live in the deep, dark places where this poison has not yet reached, hiding from a sky they cannot see. But this little bacterium, our traveler, has performed a miracle of evolution. It did not hide from the poison. It did not fight it, it invited it in. It learned to dance with the fire. Over countless generations, it developed a breathtakingly complex suite of proteins and enzymes, a form of internal machinery that could not just withstand oxygen, but could use it. Imagine a blacksmith learning to harness a lightning bolt. This is the scale of the achievement. This bacterium can draw in a molecule of oxygen from the water and use it as a hammer to shatter a molecule of sugar. And the result is not the gentle sigh of energy that the Archean knows. It is an explosion, a controlled microscopic supernova that releases a cascade of power. This process, aerobic respiration, is the bacterium's secret. It is its magic. Step inside this tiny body. The interior is not a calm, meditative space like the Archeans. It is a humming, thrumming powerhouse. While it too is a prokaryote with its genetic code floating free, its inner membrane is a different world. It is studded with the intricate machinery of respiration, 1,000 tiny forges all glowing with an inner fire. There is a constant, palpable charge in the air, a sense of immense potential held in a state of perfect readiness. It is a living battery, a charged capacitor, holding a storm of energy within its microscopic walls. The numbers tell a story that beggars belief. For every one molecule of fuel our Archean can slowly process for a single coin of energy, this bacterium, using oxygen, can extract nearly 40. It is not a small difference. It is the difference between a single candle and a blazing searchlight. The difference between a whispered word and a thunderclap. This incredible wealth of energy transforms every aspect of its being. It is this energy that spins its flagellum, turning it from a passive drifter into an active predator. Can now hunt, chasing down floating morsels of organic matter with relentless speed. Can flee, escaping dangers or toxic environments. It has choice. It has agency. This energy also funds a life of incredible resilience. When its membrane is torn, repairs are made in an instant. When it encounters a stress, it can mount a rapid, robust defense. And most importantly, it can replicate with astonishing speed. While the Archean divides with the slow grace of a setting moon, this bacterium can divide in a matter of minutes. Its life is a brilliant, frantic burst of creation. It does not just survive. It proliferates. It burns bright. But this power, this brilliant life, comes at a cost. It is a life lived on a knife's edge. This bacterium is a specialist, and its specialty has made it a dependent. It is addicted to its own fire. It must constantly seek out the two things it needs to survive: organic fuel and the oxygen to burn it. If it drifts into one of the vast, oxygen-poor zones of the deep ocean, its engine sputters, its light dims, its frantic dance slows to a crawl, and it will quickly perish. Its existence is a tightrope walk between fuel and fire. And so, it is also vulnerable. This tiny, energy-rich parcel of life is a tempting prize. It is a miniature feast, a nutritious morsel in the sparse ocean. Its small size makes it fragile. Its constant motion makes it conspicuous. Its life is brilliant, but it is also precarious, a constant race against its own consuming fire and the emptiness of the world around it. Here they are then, our two protagonists, a portrait in contrasts. The great, slow Archean, a being of space and substance, a living sanctuary with all the room in the world, but not enough energy to furnish it. And the small, swift bacterium, a being of pure power, a living engine overflowing with a ferocious energy, but with no fortress to protect it, no safe harbor for its fire. One is a house without a furnace. The other is a furnace without a house. They float in the same dark water, two perfect, incomplete solutions. The world is changing around them. The slow, creeping tide of oxygen is rising, creating both a deadly crisis and a breathtaking opportunity. The stage is being set for a collision, a chance encounter in the dark that is not an act of violence, nor of love, but of simple, profound, and world-altering necessity. Section 4, A World Transformed, the Oxygen Crisis. Let us now drift upwards, leaving our two lonely protagonists for a moment in the deep. Let us rise through the water column, up, up, towards that distant, hazy sun. The water grows warmer, the coppery light more intense. Here, in the sun-drenched shallows of the global ocean, we find the source of the great change. Here, we find the architects of the world's first apocalypse. They are not monsters. They are not villains. They are, in their own way, a triumph of life's ingenuity. They are the cyanobacteria. Picture them, if you will, as living carpets of green-blue velvet, coating the submerged rocks in the shallow seas. They are life's first true sun-eaters. They have perfected a breathtaking new art form, photosynthesis. They have learned to do what no life had ever done before. They learned to drink sunlight. They could take the simple, abundant materials of the world, water and carbon dioxide, and, using the energy of the young sun, weave them into sugar, into life itself. It was a revolution, a way to create endless food from nothing but light and water. These cyanobacteria flourished, spreading across the sunlit surfaces of the planet, painting the sterile world with the first vibrant strokes of green. They were a wild success, a biological explosion. And with every photon of light they consumed, with every molecule of sugar they created, they released a tiny puff of waste. A single molecule exhaled as a sigh of chemical satisfaction. This waste product was oxygen. For 1 billion years, the world had been an anaerobic place. Life was built on a chemistry that was slow, gentle, and utterly intolerant of this new gas. The earth itself acted as a great sponge. For millions of years, every puff of oxygen released by the cyanobacteria was immediately absorbed. It reacted with the iron dissolved in the oceans, with the minerals on the seafloor, with the gases in the atmosphere. The planet was, in essence, holding its breath, soaking up the poison as fast as it was produced. Imagine the ocean during this time. As the oxygen seeped into the water, it found the dissolved iron that had been floating there for eons. And the two reacted. The oxygen, that hungry ghost, instantly seized the iron, and together they formed a new substance. Iron oxide. Rust. This newly formed rust, heavier than water, began to rain down through the ocean, a constant, slow-motion drizzle of reddish-brown particles. Day after day, century after century, this slow rain of rust settled on the seafloor, forming vast layers of iron-rich sediment. The entire planet was bleeding rust. The oceans were literally being cleansed of their iron, a process that would paint the geological record with the beautiful, striped patterns we now call banded iron formations, the silent, stone testimonies of a world turning inside out. But the cyanobacteria were relentless. Their success was too great. They continued to pump out their oxygen waste, faster and faster, until finally the world could absorb no more. The great sponge of the planet became saturated. The dissolved iron was gone. The surface minerals were all oxidized. And so, for the first time in Earth's history, free oxygen began to accumulate. First in the water, and then, inevitably, it began to leak out into the atmosphere. This was the moment the world tipped. This was the great oxygenation event. And for the overwhelming majority of life on Earth, it was a catastrophe on an unimaginable scale. Remember our Archean, living its slow, gentle life in the deep. Its entire existence was based on a chemistry that was exquisitely sensitive, a delicate dance of molecules. Oxygen, to this chemistry, was not just a poison. It was a vandal. It was a molecular bull in a china shop. This new gas was fiercely reactive, tearing apart the fragile proteins and delicate membranes of the anaerobic world. It was a slow, inexorable fire, and it began to burn through the biosphere. A great dying began. A mass extinction event so profound it makes the dinosaurs' demise look like a minor inconvenience. Perhaps 99% of all life on Earth, the quiet, anaerobic life that had owned the planet for more than 1 billion years, was wiped out. It was not a sudden impact, but a slow, creeping plague. The world they had known, the world they were perfectly adapted for, had turned against them. Their homes became toxic, their water became a corrosive acid. We can only imagine the silence that fell across the planet. The great stillness, the retreat of life. The anaerobic organisms, those that survived, were driven into the last dark corners of the world where the poison had not yet reached. They became refugees in their own home. They fled into the deep ocean trenches, into the mud and muck of the seafloor, into hydrothermal vents, anywhere anoxic, anywhere safe. Their global kingdom had been reduced to a few beleaguered, terrified holdouts. The world was remade. The hazy, methane-orange sky was scoured clean by the reactive oxygen, slowly, over millions of years, giving way to the first hints of a transparent blue atmosphere. The stage was being set for a new kind of planet, a new kind of life. This crisis, this great dying, was also a crucible. It created a powerful, irresistible evolutionary pressure. The world was now starkly divided. There were the new territories, the oxygen-rich shallows and surface waters. This was a dangerous, high-energy frontier, a place of immense opportunity for those who could breathe the fire, and instant death for those who could not. And then there were the old territories, the anoxic depths, the safe but energy-poor ghettos where the old life forms hid. Now, think of our two protagonists in this new, divided world. The crisis has pushed our slow, gentle Archean even deeper. This world has shrunk. The encroaching oxygen is a wall, penning it into an ever smaller sanctuary. It is safe, but it is more isolated and more energy-starved than ever before. Its peaceful, stable existence is now tinged with the subtle threat of extinction. It is an exile. And our little bacterium, the master of oxygen, for it, this apocalypse is a renaissance. The poison world is its paradise. It is perfectly adapted to thrive in this new, high-energy environment. It is no longer just a curiosity. It is the heir apparent. But it is still a small, fragile thing. It has the secret to the new world, but it is tossed about by the currents. A tiny spark of life vulnerable to every random event. It has the key to the kingdom, but no castle to call its own. The world has been irrevocably broken, and in its breaking, a new tension has been created. A tension between the old world of substance and the new world of energy. A tension between the deep, safe, starving dark and the bright, dangerous, bountiful shallows. Life had reached an impasse. The old guard was trapped in the past. The new guard was too fragile to build the future. A new strategy was needed. Something radical. Something that could bridge the gap between these two worlds. Something that could combine the safety and substance of the old with the ferocious energy of the new. The pressure was mounting. The pieces were on the board. The world was waiting for a miracle born not of design, but of desperation and pure, dumb luck. Section 5. The Fateful Encounter. A Chance Ingestion. Let us return now to the deep, silent theater of the primordial ocean. The stage is set, the world has been transformed, and our two protagonists are adrift in the aftermath. The great, slow Archean floats in its ancestral darkness, a refugee in a world its kind once owned. The small, vibrant bacterium zips through the twilight zones, a master of the new chemistry, but a nomad without a permanent home. They are two solutions to the puzzle of life, each incomplete, each holding what the other lacks. And the ocean, in its endless, thoughtless wisdom, begins to stir. Imagine the currents of this ancient sea. They are not like the swift, defined currents of our modern world. They are slow, ponderous, continental in scale. They are invisible rivers of fate, stirred by the faint warmth of deep-sea vents and the distant, gravitational pull of a much closer moon. And these currents, over uncounted spans of time, begin to gently, imperceptibly, guide our two lonely selves towards one another. This is not destiny in the way we write it in our stories. There is no grand plan, no knowing intelligence guiding their paths. It is a meeting choreographed by pure, beautiful chaos. The universe is a vast, echoing chamber of random events, and every now and then, two notes sound at the same time, creating a harmony that has never been heard before. You can feel the moment approaching. The water between them thins. The bacterium, on its tireless pilgrimage for fuel and fire, senses a faint chemical trail in the what-era subtle whisper of the Archean's slow metabolism. To the bacterium, it is simply a sign of potential food, a ghost of organic matter. It adjusts its course, its tiny flagellum spinning with renewed purpose, driving it towards the source of this faint promise. The Archean, for its part, senses nothing, continues its slow, dreamlike drift. It is a living island, and a tiny, energetic ship is now approaching its shores. Then, contact. It is a touch so light it would register on no instrument we could build. The sleek, firm outer wall of the bacterium brushes against the soft, yielding membrane of the Archean. For the bacterium, it is a sudden change in pressure, a collision with something immense and soft, like a ship running aground on a sandbank made of mist. For the Archean, it is a new sensation on its ancient skin. Not a sharp poke, but a persistent, localized pressure. Presence. A thing is there at its border, and now, a deep and ancient reflex is triggered within the larger cell. It is a reflex honed over 1 billion years of simple survival. When the Archean encounters a floating particle of organic matter, a dead cell, a flake of biological debris, it has a simple way of feeding. Cannot open a mouth it does not have. Instead, it must flow around its meal. But the bacterium is not dead debris. It is alive. It is vibrant. And it is right there, pressing against the Archean's living wall. The ancient programming kicks in, but this time the context is new. The Archean's membrane, that fluid, living boundary, begins to respond. It does not recoil. It does not attack. It yields. Imagine a slow, silent wave cresting on a windless sea. The membrane at the point of contact begins to indent, to dimple inwards, forming a gentle cup around the small, firm body of the bacterium. This is not an act of aggression. It is a slow, ponderous, and utterly unintentional embrace. The Archean is not thinking, "I will consume this." It is simply reacting. It is a vast, clumsy giant, performing an old dance with a new and utterly surprising partner. The bacterium, for its part, is now trapped. Its frantic swimming now pushes it deeper into the growing pocket. The walls of the Archean are rising up around it on all sides, a soft, translucent prison closing in. But it is a prison with no bars, a cage made of cloud. Then the world changes. The edges of the cup-like depression on the Archean surface continue to stretch towards each other, high above the captured bacterium. They move with the slow, inexorable grace of two clouds merging in a calm sky. And then they touch. The lipid molecules of the membrane, ever eager to connect with one another, seamlessly fuse together. The kiss is complete. In that silent, microscopic instant, the boundary is redrawn. The bacterium is no longer in the ocean. It is somewhere else. It is inside. It has crossed a threshold. The great, dark ocean has vanished, replaced by the warm, soupy, an utterly alien world of the archaean cytoplasm. The bacterium is now floating within its larger host, encased in a small, protective bubbly vacuole made from the very piece of the archaean's membrane that had enveloped it. It has brought a small piece of the outer world in with it. A profound silence must have fallen upon them both. Imagine the archaean's confusion. This thing that it has ingested is not like the usual inert morsels. It does not yield. It does not break down. The archaean releases its simple digestive enzymes into the vacuole, the tools it uses to dissolve its food. But they have no effect. The bacterium's own sturdy cell wall, a product of its own advanced evolution, protects it completely. The meal will not be eaten. The guest refuses to dissolve. There is now a foreign, living, and indestructible presence within its own body. A second life, humming with a strange energy, has taken up residence inside the sanctuary of the self. And imagine the bacterium's state. One moment it was navigating the infinite ocean. The next it is contained. The chemical signals are all different. The pressure is gentle and constant. The world is no longer a vast emptiness, but a confined, nurturing space. It is no longer buffeted by currents. It is no longer exposed. It is safe. It is protected from the vast, random dangers of the outside. It is in a harbor, a living, breathing harbor that it never sought. This was the moment, the pivotal, accidental, world-altering event. It was not predation. It was not a partnership. It was not yet anything. It was simply an anomaly, an accident of physics and biology. A large, simple cell, in a clumsy attempt to eat, had accidentally provided a safe house for a small, powerful cell it could not digest. A key had turned in a lock that neither of them knew existed. They are now together, two strangers in the most intimate proximity imaginable, one living inside the other. The great, slow host and the tiny, fiery guest, bound together by a failed meal. What happens now? Does the host eventually expel the indigestible guest? Does the guest, starved of the oxygen it needs, simply die? Or does something new, something utterly unprecedented, begin to happen in this strange, new internal world? The ancient partnership has not yet been forged, but the two partners are now, for the first time, in the same room. Section 6, An Internal World, the First Symbiosis. And so, they float together, a single being composed of two separate lives. The archaean, this new, composite creature, continues its slow, aimless drift through the deep ocean. But its inner world is now a stage for a drama of unprecedented intimacy. This is not a partnership forged in understanding, but a quiet, molecular negotiation taking place in the dark. Let us remain inside the host, in this cathedral of cytoplasm. For the first moments, hours, perhaps even days, this new arrangement is one of profound confusion. A standoff. The archaean host continues to treat the bubble containing the bacterium as a recalcitrant piece of food. It periodically bathes the vacuole in digestive enzymes, which splash harmlessly against the bacterium's resilient coat. It is a landlord endlessly trying to dissolve a tenant who is made of stone. The attempt is futile, a waste of the host's precious, limited energy. It is a case of cosmic indigestion. And for the bacterium, the guest, this new reality is a paradox. It is a prison of perfect safety. The chaotic, dangerous world of the open ocean is gone, replaced by a gentle, stable environment. It is no longer hunted. It is no longer buffeted by currents. But it is also cut off from its lifeline. Here, in the deep, anoxic cytoplasm of its host, there is no free oxygen to fuel its inner fire. Its powerful engine of respiration, the very thing that defined its vibrant existence, has sputtered to a halt. Its flagellum, that proud propeller, ceases its spin and lies still. the bacterium goes dark. It enters a state of dormancy, a low-power hibernation, waiting for a breath of the fire gas that may never come. It is a castaway on a living island that has everything but the one thing it needs to truly live. The arrangement is stable, but it is sterile. It leads nowhere. A host wasting energy on a guest it cannot digest. A guest slowly starving in a fortress of plenty. If this were the end of the story, they would simply drift together until one or both perished, a forgotten footnote in the history of life. But life is leaky. Perfection is not its way. The membrane of the vacuole, that bubble prison, is not a wall of impermeable steel. It is a living, breathing interface, a part of the host cell. And it has pores, channels, and a natural permeability. It is a room with porous walls. And through these walls, the first tentative conversation begins, not in words, but in molecules. From the host side, the soupy cytoplasm is a rich broth. The archaean has already done the first stage of work. It has absorbed simple compounds from the ocean and broken them down into more refined organic molecular spirivate, simple sugars, the building blocks of its own body. These are small molecules, and they begin to slowly, passively, diffuse across the vacuole membrane, seeping into the bacterium's small prison. For the bacterium, it is like manna from heaven. The very fuel it used to hunt for in the vast ocean is now being delivered to its doorstep, effortlessly. The island it is stranded on, it turns out, is made of food. But food is useless without the fire to burn it. The oxygen is still missing. And here, chance re-enters the story. The archaean, in its endless, random drift, is not always confined to the deepest, most oxygen-starved waters. Sometimes the slow currents carry it upwards, towards the edge of the twilight zone, where the new, oxygenated world of the surface leaks down into the ancient world of the deep. Here, trace amounts of the deadly oxygen poison seep into the water. This is normally a moment of peril for the archaean. When these oxygen molecules diffuse across its outer membrane, they wreak havoc, damaging its delicate internal chemistry. It must expend precious energy to repair this oxidative damage, or else retreat to safer waters. But now something is different. Now it has a guest. As the stray molecules of toxic oxygen seep into the archaean's body, they do not just float aimlessly. They are drawn by the irresistible pull of chemistry towards the one place in this entire living system that knows what to do with them. They diffuse across the cytoplasm, across the wall of the vacuole, and they find their way to the dormant bacterium waiting within. And a switch is thrown. Inside the bacterium, a single molecule of oxygen arrives. It is the key it has been waiting for. Instantly, its dormant machinery roars back to life. The inner fire is reignited. It takes the fuel generously provided by its host, and it uses the invading oxygen as the spark to burn it. The lightning storm of aerobic respiration, silent for so long, crackles once more in the heart of the host. In that instant, two miracles happen at once. The first miracle is for the host. The bacterium, in its frantic effort to power itself, becomes an internal purification system. It gobbles up the toxic oxygen molecules as fast as they enter the host cell. The poison that was once a threat to the archaean is now being intercepted and consumed by its internal guest. The bacterium, by saving itself, has accidentally become a bodyguard. It is detoxifying its own home. The host is now safer in the dangerous borderlands than it ever was before. It has a shield against the new, poisoned world, and that shield lives within it. The second miracle is even more profound. When the bacterium burns its fuel with oxygen, it creates an enormous amount of energy. It captures this energy in the form of a small, universal molecule, a little parcel of pure power. This molecule is called adenosine triphosphate, or ATP. It is the battery pack of all life. The bacterium makes a vast fortune of these ATP molecules, more than enough for its own needs. And life, as we said, is leaky. The tiny bacterium, now humming with a furious surplus of energy, cannot contain all of its new wealth. These small ATP molecules, these coins of pure energy, begin to leak back out. They diffuse out of the bacterium across the porous membrane of the vacuole and into the cytoplasm of the archaean host. Imagine the host's perspective. For 1 billion years, it has lived a life of careful, meager thrift, sipping energy from sulfur compounds. And now, suddenly, a river of pure power begins to flow into its own body from an internal source. It is not the slow, smoldering candle flame it is used to. It is cellular sunlight, a torrent of ready-to-use, high-grade energy, gifted to it by its guest. The host, which had been wasting energy trying to digest its tenant, is now receiving a 100-fold return on its accidental investment. The indigestion has turned into a power plant. A feedback loop of breathtaking elegance has been established, born entirely of accident and necessity. The host provides the guest with a safe house and a steady supply of raw fuel. The guest takes that fuel, uses invading oxygen to burn it, and in doing so, both protects the host from the poison and floods its body with a massive surplus of clean energy. The host is no longer just a simple archaean. It has been transformed. It now possesses an internal engine, a secret star that burns within it. It has the energy to do things it could never have done before, to grow larger, to build new things, to move with purpose. The guest is no longer a prisoner. It is the engine room of a great living ship, safe in the harbor of its hull, tirelessly powering its voyage. They are no longer two. They have become a single functioning system, a composite being, a hybrid entity the likes of which the world has never seen. The ancient partnership is no longer just a possibility. It is a reality, a fragile, tentative reality, based on leaky membranes and chance encounters, but a reality nonetheless. The first chapter of a new kind of life has just been written. Section 7, The Genetic Bargain. Sealing the Pact. The new being, this chimera of two ancient lines, floats in a state of grace. It is a marvel of accidental engineering, a house warmed by a captive star. The symbiosis is functional, beautiful, and profoundly beneficial. The host provides sanctuary, the guest provides power. It is a perfect, self-contained economy. But this delicate arrangement, born of chance, is still just that, an arrangement. It is a handshake deal, a temporary truce held together by leaky membranes and good fortune. For the partnership to last, for it to become the foundation for all future complexity, it must become permanent. It must be sealed in a way that can never be broken. The story now turns from a chance encounter to a silent negotiation. A genetic bargain must be struck. Think of the problem from the host's perspective. It has this incredible new power source humming away inside it. Life has never been better. The time comes, as it must for all life, for it to divide, to pass its legacy on. It performs its ancient, graceful dance of replication. Its own genetic scroll is copied, the cell elongates, and it pinches itself into two perfect daughters. But a terrifying question arises. What about the guest? There is no guarantee that the guest bacterium will divide at the same time. There is no system in place to ensure that when the host splits in two, one of the precious power plants passes into each new daughter cell. It is a matter of pure luck. The host might divide, and both bacteria might end up in one daughter, leaving the other an impoverished throwback, a simple archaean once more, cast back into the world of energy famine. Or worse, the host might divide and leave the guest behind entirely. The newfound magic would be lost in a single generation. The miracle would be a fleeting anomaly. And there is a danger from the guest's side, too. The bacterium, safe in its warm haven, swimming in a sea of fuel, might begin to replicate on its own schedule. Its own ancient programming urges it to multiply. What if it divides faster than the host? 2 bacteria become 4, then 8, then 16, all humming with power, all packed inside a single host cell. The guest, in its success, could become a cancer, a fire that consumes the house from within. The host would be burst apart by the very engine that was meant to save it. This partnership, for all its beauty, is unstable. It is 2 lives sharing a body, but with 2 separate minds, 2 separate sets of instructions, 2 clocks ticking to different rhythms. For this to work, there must be only one conductor, one central command. The host must take control. It must find a way to orchestrate the life of its guest, to synchronize their fates so that they rise and fall as one. The solution was as elegant as it was audacious. It did not involve building new walls or new lines of communication. It involved a theft, a surrender, a transfer of the most sacred thing a life form possesses. Its blueprint, the story, the soul written in the language of DNA. The process likely began as another accident. Within the host's cytoplasm, one of the guest bacteria might have reached the end of its life. It dies. Its sturdy wall breaks down, and its contents spill out into the host's interior. And among the debris is the bacterium's own genetic scroll, its single circular chromosome. Now imagine the host's internal machinery. It is a world of constant activity, with enzymes and proteins whizzing about, performing their duties. Some of these are scavengers programmed to break down and recycle stray molecules. But others are builders, constantly on the lookout for useful code, for fragments of DNA that can be repaired or incorporated. When these scavenger proteins stumbled upon the guest's genetic scroll, something new happened. They didn't just see it as debris to be recycled. They saw it as a set of instructions. And the host's machinery, in its quiet, relentless way, began to read. It was like a scholar in a vast, ancient library discovering a lost manuscript from a foreign land, filled with unimaginable secrets. This new scroll contained the secrets of fire, the blueprints for the lightning-fast machinery of aerobic respiration, the complete instruction manual for how to be this vibrant, energetic being. And then, the most profound event in the history of life on Earth, after the origin of life itself, began to unfold. A great genetic migration. The host cell began to take the genes from the bacterium scroll and stitch them into its own. Page by page, chapter by chapter, the guest story was carefully cut and pasted into the host's great central library. The genes for building the respiratory machinery, for repairing it, for regulating itone by one, they were lifted from the guest's DNA and woven into the host's own chromosome. This was the ultimate act of integration. The host was taking ownership of the guest's core identity. It was saying, "Your power is now my power. Your story is now part of my story." And from the bacterium's perspective, this was the ultimate surrender. It was a genetic disarmament. As its genes migrated to the host's central command, the bacterium lost the ability to perform those functions for itself. It outsourced its own memory, its own blueprint, could no longer build its own parts from scratch, could no longer decide when to divide. It was now dependent on the host to read the instructions, build the necessary proteins, and ship them back to it. Why would life permit such a thing? Because it offered the guest the one thing it valued above all else: permanence, ultimate security. By surrendering its autonomy, it was guaranteed its existence. It no longer had to worry about its own survival. The host was now genetically programmed to maintain it, to repair it, to replicate it. The host needed the guest to survive. Their fates were now, and forever, bound together at the most fundamental level possible. Not all the genes were transferred. A tiny handful remained behind inside the bacterium, a few essential pages from its original story. These were the genes for the most immediate and vital parts of the respiratory process, instructions that needed to be on hand locally for the power plant to function moment to moment. It was too inefficient to wait for instructions to be shipped from the central office for these critical tasks. So the guest kept a sliver of its old self, a ghost of its former independence, written in a dialect only it could understand. The contract was sealed. The bargain was struck. The guest could now never leave. It could not survive on its own if it were somehow cast out of the host. The instructions for how to be an independent being were gone, stored away in a library it could no longer access directly. It was no longer a guest. It was a permanent resident, an organ, an organelle, and the host was no longer a simple Archean. It had a central library, its nucleus, that now held the blueprints for a life of unimaginable energy. It had complete control over the power plant that now lived within it. It could ensure that when it divided, the power plant divided with it. The two were now and forever one, a single, integrated, complex being. The first eukaryote had been born, forged in the silent fire of this genetic pact. Section 8. A new blueprint for life, the eukaryote. And so, the transformation is complete. The pact, sealed in the universal language of DNA, has created something entirely new under the young sun. The being that floats before us now is no longer an Archean. It is not a bacterium. It is not a simple composite. It is a new and higher form of life, an integrated whole, greater than the sum of its parts. It has a new name, a name that speaks of its profound new architecture, eukaryote, the cell with a true kernel, a true nucleus. Let us contemplate this new creation. For a billion years, life had only two basic designs, the bacteria and the archaea. Both were prokaryotes, life before a kernel. Both were elegant, successful, but ultimately trapped in simplicity. This new cell is a revolution. It is the third great domain of life, born from the fusion of the other two. It is a living testament to the power of partnership. The defining feature of this new life is not its structure, but its wealth. The Archean lived a life of profound energy poverty. It was a humble peasant carefully rationing every crumb of energy it could scavenge. Its entire existence was governed by this scarcity. The eukaryote, by contrast, is a king. It has inherited an unimaginable fortune. The tiny, captive power plants humming away in its cytoplasm have given it access to an ocean of energy. It has gone from living on a handful of copper coins to owning a treasury of gold. This staggering energy surplus changes everything. It shatters the ancient prisons that had constrained life for eon. Remember the prison of size? The law of geometry that said a cell could not grow large because its surface area couldn't keep up with its volume? That law is now broken. The eukaryote no longer needs to rely on its outer skin to gather energy. Its energy is generated internally by hundreds, even thousands, of tiny mitochondria scattered throughout its cytoplasm. It is no longer a tiny hut trying to survive on what it can gather from the surrounding yard. It is a sprawling city with a power grid, with power plants distributed wherever they are needed. And so it begins to grow. For the first time, a single cell can become vast, a giant compared to its prokaryotic ancestors, 1,000 times larger in volume. It swells with its newfound power, becoming a true presence in the water, a visible speck of life. This size alone makes it a formidable being, a fortress in a world of microscopic skirmishes. With size and energy comes the greatest luxury of all, the ability to build. The energy-starved Archean could only afford the most basic of structures. Its interior was an open, Spartan room. The eukaryote, with its boundless budget, begins to furnish its internal world. It becomes an architect of itself. It starts to build specialized compartments, organized structures to handle the new complexities of its existence. It becomes a cell of rooms. And at the heart of this new cellular empire lies its greatest innovation, the nucleus, that true kernel, The host's genetic scroll, now interwoven with the stolen genes of its guest, is no longer left to float unprotected in the chaos of the cytoplasm. It is encased within a double membrane, a secure fortress at the very center of the cell. It is a vault, a library, and a throne room all in one. Here, the blueprints for this entire complex operation are stored, protected from chemical damage, meticulously organized. This organization allows for a level of control and regulation that was impossible before. The cell can now turn genes on and off with incredible precision, like a master conductor calling upon different sections of an orchestra. This is the birth of complex genetic programming. And what of the guest? The tiny, fiery bacterium that started it all? It too has a new name, one that reflects its new, permanent role. It is the mitochondrion. From the Greek words for thread and granule, a name given by later scientists who saw these tiny specks inside our own cells. And there is not just one. That single, captured ancestor has now replicated, synchronized with its host. The cell is filled with a whole fleet of them. They are the honored descendants of that first brave traveler, 1,000 power plants humming in silent, loyal service, concentrated wherever the need for energy is greatest. With a protected library and a distributed power grid, the cell continues to build. It lays down an intricate internal network of protein filaments, a cytoskeleton. This is both the cell's skeleton, giving it shape and strength, and its highway system, a network of tracks along which molecular cargo can be transported from one area to another. It builds ribosomes, tiny workbenches where the instructions from the nucleus are translated into proteins. It constructs an endoplasmic reticulum, a vast, folded membrane that works as a factory floor, and a Golgi apparatus, a cellular post office that packages and ships finished products to their final destinations. The cell is no longer a simple sphere. It is a bustling, dynamic city, with a central government, a power grid, a logistics network, and specialized factories, all working in a perfectly coordinated hum of activity. This new internal complexity gives rise to a new way of being in the world. The eukaryote is not a passive drifter. With its cytoskeleton, it can change its shape. It can extend parts of itself outwards like exploratory arms. It can move with a new kind of deliberate, flowing grace, a process called amoeboid movement. It has become an active participant in its own destiny. And it has perfected the very act that began this whole story. It has become a professional predator. Using its new strength and flexibility, it can actively hunt and engulf other, smaller cells. The clumsy, accidental ingestion that captured its first mitochondrion has been refined into a deadly and efficient tool. This new being is a titan, a hunter, a king in the microscopic realm. It is the apex predator of its time. This is the blueprint. A cell with a protected nucleus, an army of internal power plants, and a suite of specialized organelles to manage its complex life. It is a design of staggering power, efficiency, and most importantly, potential. It is a modular system, a design that can be tweaked, adapted, and built upon. For 2 billion years, life had been a world of single-celled simplicity. But now, in the quiet depths, something new has been forged. A cell with the energy of a star and the complexity of a city. This single cell, this first eukaryote, holds within its living walls the seed of every forest, the ghost of every beast, the potential for every thinking mind. It is the common ancestor of every plant, every animal, every fungus, every amoebivory complex organism that has ever lived. It is a promise whispered in a 2-billion-year-old sea. A promise of a world of breathtaking complexity yet to come. Section 9. The explosion of complexity from one to many. For a long time, perhaps hundreds of millions of years, this was the new plateau. The world was now populated by these magnificent, single-celled kings. Eukaryotes, powered by their internal stars, had become the dominant life forms in the ocean, hunting, growing, and thriving in a world of their own making. They were a stunning success, a masterpiece of biological engineering. But a king is still just one person. A city is still just one city. The next great leap for life would not be to make the cell more complex, but to make something new from the cells. The question whispered on the currents was no longer, how can one cell be better, but rather, what can many cells do together? The story now shifts from internal politics to the birth of society. Imagine one of our eukaryotic titans after it divides. The graceful pinching of its membrane, the careful separation of its contents, the creation of two perfect, identical daughters. In the old world, these two daughters would have immediately drifted apart, two independent beings going their separate ways to live separate lives. But with the vast energy surpluses now available, a new possibility emerged, a new behavior. What if they stayed? What if, after dividing, the two daughter cells remained connected by a thread of cytoplasm or adhered to each other with a new kind of sticky protein on their surfaces? They would become a colony of two, a tiny dumbbell of life tumbling through the water together. Then they divide again. Now it is a colony of 4, then 8, then 16. A small, shimmering sphere of identical cells, a living cluster of grapes. At first, this was simply a strategy for safety. A single cell is a vulnerable target, but a floating sphere of 100 cells? That is a fortress. It is too big for most other single-celled predators to swallow. There is safety in numbers. They were a community, but a community of equals. Each cell in the sphere was identical, each one a jack of all trades. Each one had to find its own food, power itself with its own mitochondria, and, crucially, each one retained the ability to reproduce. They were a cooperative, not yet a single, unified being. But living together presents new challenges and new opportunities. Imagine one of these spheres like the beautiful green algae volvox. The cells on the outside of the sphere are in a different position from the cells on the inside. The outer cells are the first to encounter food, the first to sense danger, and they are also the ones whose flagella can best propel the entire colony through the water. The inner cells are protected, but they are also shielded from the outside world. And here, a new and revolutionary idea took root in the quiet logic of evolution. The idea of specialization, the idea of sacrifice for the greater good. Inside this sphere of equals, a silent pact was made. Some cells began to take on specific roles. The cells on the outside might specialize in movement, their flagella beating in a coordinated rhythm to swim the entire colony towards the light. In doing so, they might give up other functions. They might even give up the most fundamental right of all life, the right to reproduce. They became sterile worker cells, dedicating their entire existence to serving the whole. This was a moment of profound significance. When a cell voluntarily gives up its own immortality, its own lineage, to serve the colony, that colony ceases to be a simple cooperative. It becomes something more. It becomes a true individual, a multicellular organism. It is a body composed of many cells working in concert with a shared fate and a division of labor. The single hut has become a village with farmers, builders, and guards all working for the survival of the village itself. This invention of multicellularity, this leap of faith into cooperative existence, did not happen just once. It was such a brilliant idea that it evolved independently, time and time again, in different eukaryotic lineages. It was the key that unlocked the door to a world of unimaginable scale and form. From that single ancestral eukaryote, with its nucleus and its mitochondria, the great tree of complex life began to branch and branch and branch again. One great branch took the invention of multicellularity and performed a second act of the same magic that had started it all. One of these new, hungry eukaryotes, perhaps 1 billion years ago, did something familiar. It engulfed a smaller cell. But this time, the meal was not an energy-making bacterium. It was one of those cyanobacteria, the sun-eaters from the surface waters, the very beings that had first poisoned the world with oxygen. And once again, the meal refused to be digested. The eukaryote, this house with a furnace, had now swallowed a sunbeam. Another symbiotic pact was made. The captive cyanobacterium, safe inside its new host, continued to do what it did best: photosynthesis. It harvested the energy of the sun, creating sugar from light and water. This tiny, green captive became the chloroplast. and the kingdom of plants was born. These new beings were masters of creation. They had not one but two power sources, the mitochondria to burn fuel for energy and the chloroplasts to create fuel from pure light. They were self-sufficient autotrophs. First, as simple green algae, they filled the oceans. Then they began to creep onto the barren, rocky shores. Using their newfound energy, they built rigid walls of cellulose, structures strong enough to stand up against the pull of gravity. They wove sunlight into substance, creating roots to draw water, stems to reach for the sky, and leaves to drink the light. They were the silent, patient architects who painted the sterile brown continents with vibrant, living green. They breathed out the very oxygen that their own mitochondria and the mitochondria of all other complex life would crave. Another great branch of the eukaryotic tree took a different path. These organisms did not learn to eat light. Instead, they perfected the art of external digestion. They became the great recyclers, the decomposers. This was the kingdom of fungi. Instead of engulfing their food, fungi would grow upon it, releasing powerful enzymes into their surroundings to break down dead organic matter, fallen trees, dead animals, the refuse of the living world. They were the planet's digestive system. They didn't develop into moving, active bodies, but into vast, hidden networks of fine threads called mycelium, a silent, intelligent web spreading through the soil. The mushroom we see is just the fleeting, visible fruit of this vast, invisible kingdom. They are the quiet librarians of decay, unlocking the nutrients from the dead and returning them to the soil, making life possible for the plants once more. And then there was a third great branch. The one that took the original predatory nature of that first eukaryote and elevated it to an art form. This branch did not make its own food, nor did it decompose the dead. It survived by eating other living things. This was the kingdom of animals. This lineage specialized in movement and sensation. The cells of this branch learned to communicate with each other using electrical signals, forming the first simple nerve nets. They learned to contract in unison, creating the first muscles. They developed from simple, sponge-like colony little more than organized filters into creatures with mouths, stomachs, and senses. The story of the animal kingdom is the story of the predator and the prey, a billion-year arms race of speed, armor, claws, and camouflage. It is the story of desire and pursuit. About 540 million years ago, this animal branch exploded in a frenzy of creativity known as the Cambrian explosion. In a geological blink of an eye, the blueprints for almost every major animal body plan that exists today were laid down. The world was filled with strange and wonderful creatures, swimming, crawling, and burrowing through the seas. And so, the world you know begins to take shape. A world of towering redwood trees silently weaving light into wood. A world with vast, hidden fungal networks quietly managing the cycles of life and death. A world of animals, from the smallest insect to the largest whale, all moving, eating, and living. And every single one of them, from the petal of a rose to the cap of a mushroom to the tip of your own finger, is built from eukaryotic cells. Every single one is a society of cells. And every single one of those cells, in every one of those beings, carries the same ancient legacy, a central nucleus, and humming away faithfully within it the tiny, fiery ghosts of that first captured bacterium. The mitochondria. The ancient partnership lives on, the silent engine powering all the magnificent, diverse, and beautiful complexity of our world. Section 10. The ancient echo, the legacy within you. And now where does this story end? It doesn't. It simply comes home. It comes to you, resting here, in the quiet of this moment. For this grand, epic tale of ancient oceans and microscopic struggles is not a history lesson about something that happened long ago and far away. It is the story of your own life being told in the present tense inside every part of you. Let your awareness settle for a moment. Feel the gentle weight of your body, the soft fabric against your skin, the slow, rhythmic rise and fall of your own breath. You feel like a single, unified being, a self. But this feeling, this sense of I, is the beautiful, emergent illusion created by a community of staggering size. You are composed of somewhere between 30 and 40 trillion individual cells. Trillions of lives all working in concert to create the singular experience of being you. And if we were to take a journey into any one of them, we would find our story is not over. Imagine we could shrink down, smaller than a speck of dust, and travel into the living landscape of your own body. We pass through the layers of your skin into a single living cell. And what do we find? The world inside the cell is a bustling, vibrant metropolis, a place of breathtaking complexity. And its architecture is wonderfully, profoundly familiar. At its center, we see the great, fortified library of the nucleus holding the master blueprint of you, the immense genetic code inherited from your parents. Surrounding it is the cytoplasm, a world teeming with highways, factories, and messengers, a city that never sleeps. And scattered throughout the city, humming with a quiet, tireless energy, are the power plants. Hundreds, sometimes thousands of them in a single cell. They are small, oblong shapes, the descendants of that first, brave, fire-eating bacterium. They are your mitochondria. You are the host. You are the descendant of that great, slow archaean who, in an act of accidental grace, opened its doors 2 billion years ago. Your very cells are the living legacy of that first successful partnership. And the ancient contract is still in force, reenacted with every single breath you take. As you lie here, you are breathing. You draw in the air of your room, and with it, you draw in oxygen. That same volatile, dangerous, life-giving gas that caused the great crisis so long ago. This oxygen enters your bloodstream and is delivered as a precious cargo to every one of your 40 trillion cells. And what happens when it arrives? When this ghost of an ancient poison seeps into your cells, the mitochondria, the children of the ancient guest, rise to meet it. They welcome it. They are the only ones who know the secret dance. They take the fuel from the food you have eaten, and using that very oxygen you just breathed in, they perform the same miracle of aerobic respiration. They tame the fire. They burn the fuel. And in return, they release that same torrent of energy, that same river of ADP molecules that floods the cell with life. The warmth of your own body is the collective exhaust heat from trillions of these ancient fires. The thought you are thinking right now is powered by them. The steady, reassuring beat of your heart is fueled by their tireless work. The energy you will use tonight to dream, to repair, to restore your body as you sleep, all of it is a gift from this ancient internal guest. You are a living, breathing testament to that first, fateful encounter. A walking, thinking ecosystem built on a foundation of trust forged in a forgotten ocean. And there is one last, beautiful secret, one final echo of this ancient past. If we were to look even closer at one of your mitochondria, we would find something extraordinary. Tucked away inside it, separate from the great library of your own DNA in the nucleus, is another, smaller set of instructions. A tiny, circular thread of genetic code. It is mitochondrial DNA. It is the ghost of a genome. It is the last, lingering remnant of the bacterium's original, independent blueprint. It is a faded whisper of its former life as a free-living organism, a few essential pages of its story that it kept for itself. And this tiny scroll of memory tells a story all its own. Because when your cells divide and you create new life, this mitochondrial DNA is passed down in a special way. It is inherited directly, almost exclusively, through the egg cell. From your mother. And from her mother before her, and her mother before her, and so on, in an unbroken, maternal thread of life stretching back and back and back through the immense darkness of time. It is a direct, physical link, a living filament that connects you here, now, to that first eukaryotic mother, the one who first successfully brokered the peace between the host and the guest. You are not a single thing. You are a collaboration, a symphony of trillions of lives, all descended from one ancient act of union. You are a living Russian doll, a universe of cooperation contained within your skin. The story of life on Earth is not something you read in a book. It is written in the very fabric of your being. The strange, beautiful story of two cells merging to create all complex organisms is your own origin story. And so, as you settle deeper into your rest, feel the profound peace of this truth. The life within you is an ancient, unbroken river flowing through an ocean of time. The quiet hum in your cells is the sound of a 2 billion-year-old promise being kept. As you breathe out, let go of the day. As you breathe in, know that you are fueling a miracle. Let the gentle rhythm of your breath be a lullaby, a soft drumbeat connecting you to the very dawn of complex life. Rest now. Rest in the knowledge that you are a vessel of ancient wonder, a sanctuary for a story that never ends. May your dreams be peaceful and your sleep deep and restorative. Sleep well,